Hello everyone, welcome to my presentation about the history of the periodic table. So this presentation has three key vocabularies: periodic, which means recurring at intervals of time; periodic law, which is the law that states that the physical and chemical properties of elements are periodic functions of their atomic numbers. So that means that the properties of elements are related to their atomic numbers. Periodic table, and that means arrangement of the elements in order of their atomic numbers so the elements with the same properties fall into the same column or group. So by this it means the groups and periods. So elements from the same group will differ in properties than an element from a different group. So we're going to be talking about Stanislaw Canazaro, who was Italian. He was the first chemist to present a method for accurately measuring the relative masses of atoms. And this allowed chemists to agree on standard values of atomic masses, and it also allowed them to search for relationships between atomic mass and other properties of atoms. So at this stage, chemists were trying to find a relation between the different elements that they had. They had no way of sorting them. There was no periodic table. There was no table at all. They just had like a list of, at that point, maybe like 60 elements. And then came Dimitri Mendeleev. And he was Russian. He wanted to write a chemistry textbook that included standard values of atomic masses. But he faced an issue. He can't just write the atomic masses and call it a day, right? He wanted to find a way to sort them so it's easier for students to learn. And he sorted the elements according to their properties, and he organized the information just like how you organize your information for a study or an exam. And he started looking for trends or patterns in the properties of the elements until he got to the very first periodic table, which is this picture shown here. And Mendeleev realized when atoms are arranged in order of increasing atomic mass, certain patterns emerge at regular intervals. Or we could say they are periodic. Now, this table is not very easy to read, and if you were paying attention to the little details, you might see that there's question marks all over the place. Now, what do those mean? So the question marks that are in place of the atomic mass mean that he was not sure about the value he got, and maybe they should be reevaluated, or he was uncertain. It might have been because the atom was unstable or the element was unstable, so he couldn't get an accurate number, so he was almost guessing. And then there are some question marks instead of the names of the elements. What are those? Well, they are the... So basically what happened here is he found the atomic mass of an atom, but he doesn't know what element is that. So he just put a question mark and hoped that later they would be discovered. And we have, if you go to a periodic table, there's probably some element with these atomic masses. Then came Henry Moseley, and Henry Moseley found a way easier way to fill up a table. Instead of doing it by their atomic masses, he said we can do it by their nuclear charge, or more exact, the positive charge in the nucleus. He was basically talking about atomic numbers, and as we know now, he discovered that we can arrange elements by their atomic numbers, and that's how we got to the modern periodic table. Thanks for watching, and I hope you had a great day.